Next one, this is section C, C2, question C2. This is science paper 1. Science paper 1, GCE 2020. We continue. In the other video, you can watch C1. Then C2, the question is saying, figure C2.1 below shows how a solar heater on a house roof is used to warm up water for the house. This is a heater heating the water for the house. Okay, then the questions are here. Why is the panel in the solar heater black? So all they want you to explain, or all they want from you, is the uniqueness of black. So without wasting much of the time, we know that black is a good absorber. So the reason it is black, so that black color can be able to absorb heat efficiently or effectively. That is the reason. Why is the panel in the solar heater black? To absorb more heat, because black is a good absorber. B, why is there an insulator layer behind the panel? This word insulator will make us understand how to get the question. Insulators, what are insulators, or what is an insulator? An insulator is a poor conductor of heat, meaning a material that cannot allow heat to pass through. So the reason as to why there is an insulator layer behind the panel is to prevent heat loss, so that no heat is lost, because that insulator is there to prevent the heat loss, either by conduction or convection. It cannot be lost. Then C, how does the water in the tank get heated? The water in the tank, how does it get heated? We know to say heat is transferred, or rather transferred, by 3 different processes: radiation, convection, and conduction. And if we look at this diagram here, we have got the black layer there, which is there to absorb. So in simple terms, by the look of things and how it is made, heat is able to be transferred from the source to the material or to the water inside by conduction. And the water on the surface also, when it is heated, that heat is also transferred to other water molecules in the tank. So meaning by convection also, heat is being transferred and the water is heated. So the heat is transferred and the water is heated by conduction and the convection processes. Then B. Oh, B is already done. C is done. Then we go to D. On average, okay, on average, each square meter of the solar panel receives 1000 joules. Mathematically, 1 square meter, 1 meter squared, is receiving 1000 joules. Okay? Then, of energy, meaning this 1000 joules of energy. Okay, so meaning each square meter is receiving 1000 joules energy, the energy of 1000. Okay, thank you. Then, from the sun every second. Using this information, calculate the power input in kilowatts of the panel if its surface area is 2. So they want us to find the power if the surface area now is no longer 1 but 2x. This information is very wonderful. So in this case, we are going to find the power. But one thing you should know is that power has got a formula. Power is equal to energy over time. Power is what we are finding is equal to, the energy is already given here, 1000 joules. So 1000 over, what is the time? Has the time been given? Others might say no, but the time is given. Every second, this energy, per second, this energy is received. So meaning this energy of 1000 is received every second, meaning time is 1 second. That is the time, 1 second. So when we calculate, no wonder, if you calculate here, power, you are going to get 1000 watts. No wonder, if you see, this one is equal to that one. No wonder 1 joule is equal to 1 watt. Equal. That is the reason behind the physics which is here. Now, we have the power. They ask now, this power, when the surface area is 2, it is simple to use what I already put here, what I already placed here, where you just use variations to cross like this, where we'll have 2000 joules, which is our x. So our power here, if we follow the calculations I've done, is 2000. Now this is in watt. So to convert it in kilowatt, 1 kilowatt is equal to 1000 watts. So this 2000, meaning we'll say divide by 1000 to get it in kilowatts. Hence the power is equal to 2 kilowatt. This now becomes our answer. So that is our answer. Then that was D. Then we go to E. E is reading. Let me rub very well so that we can go to E. I'll use this same paper or this same page to solve. E is reading. The solar heater in the diagram has efficiency of 60%. So efficiency of this solar heater is 60%. Under normal circumstance, efficiency is equal to 100%. So if 60 is the one that the machine has, meaning 40 is wasted, it wastes 40% of the solar energy it receives. What area, so they are asking us to find the area, is equal to X. What area of the panel would be needed to deliver heat at the same rate on average as 3 kilowatts, meaning what area will be able to give us the same rate on average by the power of 3 kilowatts. I'll use two formulas to make ourselves understand it better. Number one, I'm going to use the formula which is saying X power is emitting, X is the energy. Now we want to get the 60%. So to get the 60%, we'll say 60% over 100. Remember, on average, we have 2000 watts, which is 2 kilowatts. So if we are to divide this and multiply it by that, what will be our answer? Is going to be 1.2 kilowatts. Let's keep this. This is the 60% of the 2 kilowatts that we have. So that is 1.2 kilowatt. 1.2 kilowatt. The ink is too small. Okay, 1.2 kilowatts that we get. Now, one thing we need to understand is, as we are not to find, this is not our final answer because the question is asking us to find the area. What will be the area X to give us 3 kilowatts? Given that on average the square of 2 meters square, the area of 2 meters square has given us the 60%, which is 1.2 kilowatt. Here now, what we are going to do is your cross multiplication sign, where you have 1.2 x is equal to 6 kilowatt meter squared. This is x meter squared. This is 1.2 kilowatt. So that we are going to divide by 1.2 kilowatt, divide by 1.2 kilowatt. This 1.2 and the kilowatt will go. This 1.2 and the kilowatt will go. Meaning here we are just remaining with x square meter is what has remained here. Then if we divide now 1.2, first a kilowatt and the kilowatt will go. We are remaining with, I clean my board, meaning if a kilowatt and the kilowatt will go, this side I said we are remaining with x, which is in meter squared or squared meter, is equal to. This side we have cancelled the kilowatt, we are just remaining with the meter squared. Then this 1.2 now, if it enters into 6, it will enter there 5 times. This will now tell us to say the area the area needed is equal to 5 meters squared. This is it. This is number 1 method. Now let's look at method number 2. Method number 2. Method number 2, I am going to get the quantities just from here and this, which will tell me to say the 60% is X. Okay? It is the one which is giving us 3 kilowatts. In other words, I'm saying what 60% of X will give us the 3 kilowatts. So if we are to convert it from percentages to a standard figure, we'll divide by 100. Only this side, please. I don't want to disturb this side first. First, I should find the 60% of X. The 60% of X is, or the 60% here in the figure, we can't remove it from the percentage. It's just by dividing 100, which will be 0.6. So now 0.6X, it is the one which is giving us 3 kilowatts. So now what we are going to do here is that we'll divide both sides by 0.6. Even here, 0.6. This and this will go so that we can find this power called X, which is giving us the unity that we need. So if we divide by this one, it will give us 5 kilowatt. That is the power which will be given. Now, that is not the final answer. Let's get back to the question. The first question we are told, on average, each square meter is giving us 1,000 joules. So now, on average, 1 square meter is giving us 1,000 joules. Okay? Now, how many square meters? How many square meters, X square meters, are the ones which are giving us 5 kilowatts? This one we found it, and this is the already done. So we are now going to cross multiply this times this times this. In other ways, we are going to have 5 is equal to 1,000 joules. Please, this is 1,000. This is 1,000 is equal to make it in kilowatts, we cancel the joules, meaning the zeros are going. Hence, X squared, X meter squared, it will be a 5. In case you've not seen what I've done here, I can still repeat. The first step, what is 60%? 60% is 0.6. So now, 0.6 NH of X is giving us 3 kilowatts. I think I'll use kilowatts. Joules, I'll convert them. We'll divide by 0.6. We'll divide by 0.6. This and this will go. X will be equal to be 5 kilowatts. So we know now the energy which is giving us 3 kilowatts as its 60%. Now, having this done, don't forget from the question I said each squared meter is giving 1,000 joules, which is 1 kilowatt. The already one we found, then what's the power? Then we don't know the volume, the area, which is giving us the answer found as 5 kilowatt. So what will be this? So the X meter squared, we are going to do it like this. So we'll have X meter squared kilowatt is equal to 5 kilowatt meter squared over, we'll cancel kilowatt over kilowatt. This and this will go. So X is the area, which is 5 meter squared. This is our answer. Thank you so much. God bless you all. If you have got a problem, please, you can inbox me. My number is always available to people who are serious. 0965062101 or 0975826353. Mr. Jones will answer you on this for any concern. Thank you. Bye-bye.